All right, so we'll start with the first batch of exercises, which says we have to estimate the input value of the inflection point. And again, sometimes it's not hard, sometimes it's pretty easy, sometimes it's well, it's a guess. So we'll go with what we get, and then we're going to indicate the input intervals over which each of the following types of behavior occurs. So we want to determine when it's increasing, decreasing, concave up, and concave down. So we'll have 4 parts. All right, the inflection point. Well, it looks like we're going up, then we're coming down, and then it looks like we're starting to have a little bit of curvature here. So somewhere, maybe about here, wherever that is, if I can draw a line, is going to be our inflection point. And so if that's 350 there, it's probably 380, 390, somewhere in there. So what we can say is for part A on this one, we're going to say X is going to be approximately, I don't know, maybe 385 because, like I said, 80 to 90, somewhere in there. That's what I would choose. Okay. Again, I can't tell very well. Now this one over here, it looks like it's about there. So I would choose 3. That one's a lot easier. But this one with so many points in between here, 100 points between there, I can't determine really what it is. Now with B, what do we have? Well, this function is going to be increasing and it's going to be decreasing. So we'll have increasing part and we'll have a decreasing part. Now it's going to have a concave part up and a concave part down. Okay, so where is it increasing? Well, it's increasing from here to right about there, which looks to be maybe 210 or 20. I don't know. So let's say X is going to be less than 220. Let's go with the 220. And it's going to be greater than the 0. Now here is, well, it hasn't really started increasing yet. It's still decreasing at that point. So that's really the only increasing area. Now decreasing means then we're going to go from X is going to be less than, well, it's going to be less than 500. That's the easy one. And it's going to be greater than that 220 that we said. Okay. All right. Now, where is it concave up? Well, it's going to be concave up. Well, we have to say about here, about what do we say? 385. So we can say 385. Well, 385, and X is going to be between there. And so let's see. Basically, oh, I wrote that on the wrong side. It's going to be less than X is less than the 500. Okay. And concave down is everywhere else. So basically from 0 less than X less than 385. Okay, that's what I was trying to do first, and I did the other way around. All right, so that has our inflection point increasing, decreasing, up, and down. All right, what about this one? Well, this one, we have increasing, and it's decreasing, then it's increasing, then it's decreasing again. And so where is that inflection point? Well, like I said, we kind of estimated that to be here about 3. So I'm going to say X is approximately 3. Okay, that's my inflection point. And again, maybe it's 3.1, maybe it's 3, maybe it's 2.9. I don't know, but I'm going to say it's roughly 3. Okay. Now, what about our points where it's increasing? So we'll say increasing, and then we'll have a decreasing, and then we'll have up, and then we'll have down. Okay. All right, so our concave up is going to be basically from 0 to 3. So 0 less than X less than 3. And down is from 3 to 8. So 3 less than X less than 8. So that was easy. Now increasing, well, it's decreasing here, so it's going to be increasing from, let's say about there, which is, I'm going to say 1 less than, and it's going to go all the way up to about that point, which is, well, that would be 5, but it's more than 5, so maybe 5.5, X less than 5.5, maybe. Again, who knows exactly what it is? I'm just going to say that because it's easier to estimate that. Now, where is it decreasing? Well, it's decreasing from 0 to that 1. but it's also decreasing from that 5.5 less than x less than, and then we have 8, okay? So we've broken it down. I think we have all the pieces again. And again, on ones where it's really difficult here, as long as you get close enough, that's good. Probably if I have you decide on a test, I'll make it so it's one of the simpler ones where you have an easier time of figuring out, it's roughly 2, and, that looks like it's between 5 and 6, so 5.5, and we'll be good to go there. All right. Okay, so let's say now we go to the next one. Does the scatter plot suggest a change of concavity, and what types of function or functions might be appropriate to model the data represented by the scatter plot? Linear, exponential, logarithmic, quadratic, logistic, or cubic? So we're getting a longer list now, and soon they're going to say, hey, here's a set of data. Which one do you want to use? And you have to actually model it. So we're getting to that point. So for number 11, what are we going to say? Well, does it have a change in concavity? Well, it looks like it's concave down here and then concave up here. So for A, I would say yes. What kind of functions would we have here? Well, looks like we're going down. Now this here part, we maybe could use logistic, but look at this, we're going up. And so probably that means we are going to go to infinity that way. And so that means there's only one possible way to do that, and that is going to be with our cubic. Okay. Now, if it had came down and plateaued, then we could use our logistic, but it doesn't seem to be the case here. All right, what about the number 12 here? Well, it looks like it goes up and it just continues to go up. So that one, I don't see a change in concavity, so I'm going to say no. Now this one also, because there's no change in concavity, but we change the direction, I'm going to, I guess that's A, not, I was going with number 2 here with B. So that's A. And B, I'm going to say, well, that only thing it can really be, looks like, is quadratic. Okay. All right, what about this one? A and B. So is there a change in concavity? Well, it looks like all it's doing is going down, so it's concave up, so no. Now, what would this one be? Well, we're coming down, and it's going below that 0, so it could be logarithmic. That would be one possibility. But we don't know. Maybe come down here, and then all of a sudden it might go back up. We don't know. And so we could say also quadratic. So I'm going to say logarithmic or quadratic on that one. And again, it's hard to say, but you try the two models and then see which one fits better, and then that's going to be the one you use. All right, what about A and B here? All right, well, so this one, it looks like it's just going straight up. So that one has no change in concavity. Now, on this one, that's for sure possibly going to be an exponential. That's one possibility. But on this side, well, we could come back up over here. We don't know how that data is over there, so that could also be a quadratic. Okay, so we've had a cubic, quadratic, logarithmic, and exponential as far as our choices here. So no linears, but maybe some of the other ones on before this were actually linear. So these are 4 of them that I chose out of the group that kind of gave a good broad spectrum. All right, so we'll stop there and then we'll come back with some with calculator.